In the next example, we are going to deal with some different kind of output, which is files on disk. The next example is the file CreateFile.asa. Before we even take a look at the code, let's assemble and run this file, just to see what this program does. I open a console, and then I assemble the file CreateFile.asa. Next, let's run this program. It seems like the program waits for input. Let's give it the input, for example, hello files world, and then press the return key. The program is ended. At this point, we can close the console. We can see that we get a new file here called myfile.txt. Let's open this file and see what is inside. It contains hello files world. This is basically what the program does. It just writes a file. If we try to run the program again, this time with a different input, we are going to get the following new file. We can see that we only have one file, which is my file. If we take a look inside, we can see that this time it contains something else. It contains the last input that we gave to the program. The previous file was overridden. Let's take a look now at the code. I'm going to begin from the end, from the import section. This is the end of the file, and we can see here the iData section, or the import section. As usual, we link our program to kernel32.dll. However, this time we use some additional function called CreateFile. This is a function which we haven't seen before. Let's continue to the code. The code begins by calling getStd handle in order to obtain the input handle. This is done so we can get input from the console. Next, we read the line from the console. Both of those pieces of code are things that we have seen before. We use the readFile function with the input handle to read some bytes from the console. Then those bytes are going to be kept inside input star. Input star is declared in the BSS section. At this point, we should already have the input from the user inside input star. Next, we open a file, which is basically something new. We use the CreateFile function to do this. Let's try to roughly understand the arguments for this function, even though we haven't yet looked at the documentation for this function. It seems like the first argument is a file name. If we look at the data section, we can see that indeed we have a file name here, which is, as expected, myfile.txt, just like the file we have seen here. There are some other arguments which are some kind of options. For example, there is an argument called desired access. We want to write into the file, therefore we choose generic write. There is also an argument called share mode, and we pick 0 because we don't really want to share the file. There is also an argument for security attributes here, and we pick 0 because we don't really care about it at this point. The next argument, which is called creation disposition, is set to this value, create always. This is why if we run the program again, it overrides the previous file. Next we have this argument, in which we pretty much choose the default option, file attribute normal. And finally another argument called template file, which we choose to be 0, because this is an optional argument and we don't really care about it at this point. Basically, maybe the only interesting thing that we gave to CreateFile as argument is the file name. The rest of the arguments are just arguments that we have to give to make this function work. After this function is invoked, we get as a result a handle inside EAX. Just like we get a handle from the getStdHandle function, we also get a handle which is an object of the same type from CreateFileA function. We keep this handle inside this dword, file handle, which is declared in the BSS section here. Next, we are going to write input star into the file that we've just opened. We use here the writeFile function to do it, and it is pretty much like writing to the console. However, this time, instead of giving the output handle of the console, we give the file handle that we just got from CreateFileA. This part is going to write input star into the file. Finally, we use another new function which is called close handle. We use this function to close the file. I remind you that earlier we opened the file here. Next we wrote into the file, and finally we have to close the file handle. This is done both to close the resources taken by opening the file, and also to make sure that our changes to the file has taken effect. If you forget to close file handles, strange things might happen. Therefore, make sure that you always close the file handles for every file that you open. Finally, we exit the process. Some technical note about the contents of my file. I want to view my file for a moment with a hex editor. I'm going to use Hex Workshop. I drag my file into Hex Workshop to see its contents. I can see that it contains the numbers 1, 2, 3, 4, 5, 6. But it also contains two other characters, D followed by A. This is a new line sequence. I want to mention that we got this new line sequence from the readFile function. Whenever you read a line from the console using readFile, you will also get the new line sequence, which are the two characters D and A. If we wanted, for example, to write the string to the file without the new line sequence, we could do this. In this part where we write input start into the file, we should have given bytes read -2 instead of bytes read. Later you can try to do this yourself. Let's talk a bit about CreateFile function. Let's open a browser to find this function. We go to msdn.com and next we search for CreateFile. Note that I searched for CreateFile and not for CreateFile A. I will soon explain why. I click one of the first options, for example this one. Then I get this page about the CreateFile function. The documentation for the CreateFile function is pretty large. We have in the beginning this general explanation about CreateFile. Creates or opens a file or I/O device. The CreateFile function is pretty general. It allows us to open many things. One of those things are just simple files on the hard disk of your computer. Then we can see the syntax, which contains the arguments for this function. Those are exactly the same arguments which we have described earlier. Just as an example, let's take a look at a few of those arguments and their explanation. The first one is the file name. We can see the explanation here. File name. The name of the file or device to be created or opened. You may use either forward slashes or backward slashes in this name. We can also see explanation about the desired access argument, which explains the most commonly used values are generic read, generic write, or both. About the creation disposition argument, we can see possible values for this argument. We chose create always, as you can see in our code. The meaning of this option is create a new file always. If the specified file exists and is writable, the function overwrites the file, which is really the behavior of our program. I want to discuss some other information that we have in this page, which is the requirements section. In this section, we can see that the CreateFile function could be found inside kernel32.dll. And we also have this interesting row, which says that this function has two different names, Unicode and ANSI names. CreateFile W is the Unicode version, and CreateFile A is the ANSI version. We used CreateFile A, and let me explain for a moment. Remember that CreateFile takes as one of its arguments the file name. There are two versions for this function. One version takes the file name as ASCII sequence of characters. However, there is another version for this function which takes file name as Unicode. We use the ASCII version. Therefore, we use the function CreateFile. If we wanted to use Unicode, we would have used the CreateFile function. Sometimes people forget to add the A or W in the end of this function. And then, for example, they just call CreateFile, which is a non-existent function. I want to show you, for example, what happens if you forget the A, maybe inside the import section. Maybe instead of specifying CreateFile, you specify only CreateFile. Let's try to assemble and run this new program which has an error inside of it. We can see that the assembly went successful. Now we are going to run the program. We can see that we get this error message. The procedure entry point CreateFile could not be located in the dynamic link library kernel32.dll. That is because there really isn't a function called CreateFile inside kernel32.dll. Therefore, make sure to remember to add the A suffix to this function, or maybe the W suffix if you want the Unicode version. I want to note that many API functions that deal with strings have two versions, the A version and the W version. So pay attention whenever you work with an API function that deals with string. You will have to choose whether you want to work with ASCII characters or with Unicode characters. Let's summarize this lesson. Our program first reads from the console. Then it opens the file. It writes to the file the string that we have just read from the console. And finally, it closes the file. The new functions that we have seen in this lesson are CreateFile and CloseHandle. CreateFile allows us to open or access a file. It also allows us to create files. CloseHandle allows us to close the access to a file, to release the resources taken by opening this file.